Okay, so we're working on factoring binomials, and there's only certain kinds of binomials that are even factorable. If you look at your 4-4 worksheet and you guys had to do problems like number 11, can everyone look at problem number 11 on your 4-4 for me, number 11? If you look at number 11, it also is a binomial. Do you agree with that? But what was this one? We had to take out a what in that case? A negative what? That was a negative 3y. That was a GCF problem. In each of these cases, if you look at the board, they're still binomials, but there is no GCF that can be taken out of any of them. So, and that's called a difference. So in order for you to use this particular method of factoring, we do need to make sure that it is a difference, and both of the two numbers are what we call perfect squares. And this right here that you put at the bottom of your tab in your foldable is really the formula and what you need to do. So you need to make sure that you have the a squared minus b squared equals a plus b, a minus b as part of that bottom tab. Because that's really the pattern that we're going to use each time with this particular set of factors. So let's go ahead and look at the first one. Okay, look at the first example. We'll go one example at a time. Okay, so looking at x squared minus 49. You have to, in order to be able to use this type of factoring, we have to make sure that both the first number and the second number are perfect squares. And what do I mean by a perfect square? What's a perfect square? Give me some examples of numbers that are perfect squares. 100, 121, 25, 49, 36. Nope, not 10. 9. What makes something a perfect square? 10's not, but 100 is. Not divisible by 4, but there's something about divisibility by itself. Okay? So what I mean, for example, like that, I guess that's not really the way to say it. Let's think about 25. What two numbers that are the same multiply to be 25? 5 and 5. What two numbers that are the same multiply to be 100? 10 and 10. What two numbers are the same that multiply to be 49? 7 and 7. Okay? What two numbers that are the same multiply to be 10? There aren't any. So that's why 10's not a perfect square. What two variables that are the same multiply to be x? X times x. So are both of these perfect squares? Yes. Okay? And we need to kind of think about what they are. I like to write them above, x and 7. That tells me that those are the two things that multiply to give me the perfect square. You can also think about the square root of. The square root of 49 is 7. The square root of 100 is 10. The square root of x is x. X squared is x. So I have x and 7. Those are going to be like the a and the b that you have in the formula. Okay? So we're going to use our factoring formula that we have there. And it really doesn't matter if you say a plus b first or if you say a minus b first. Or if you say x plus 7 first or if you say x minus 7. It really doesn't matter. Okay? And then you're done. You factored it. No. Yep, that easy. This is an easy one. Okay? Kind of nice, right? Nice to have an easy one for a change. All right, let's try the second one. We have to make sure that both of these are perfect squares first. Yeah. And is there a subtraction sign? If there is a plus sign here, it is not factorable. It absolutely has to be a subtraction.
So it's divisible by 5 and 12.
Okay, so 5 and 12 are the perfect squares that we would use in this case. Those are going to be our A and our B. Be careful with just 5 though. The first, it's 5x, okay? It's not just 5 because it says x squared. So you have to be careful. So it is 5x in the top. And then we have 12 because 12 squared is 144. Exactly. So based on that alone, Chris, what are my two factors? 5x minus 12 and 5x plus 12. I mean, this is not rocket science. We got this. This is easy. Come on, Miss Maggart, make it hard, Travis is saying. But we understand so far? You're just taking the square root of the numbers is really all you're doing. Pretty easy. All right, last example. Yep, you do. They're exactly the same. One's a plus and one's a minus. That's what the formula says here at the bottom. Now let's look at the last example. Well, let's everybody have a chance. Okay? In a minute, let everybody think about it. I agree, though. This has got two variables, though. Has x's and y's. Is that okay? It's okay, though, because they're both squareds, right? What if I made it even harder? What if I made this a 4?
We're still gonna be good.
We're still going to be good. Let's make it a 4. Let's challenge ourselves. So make it a 4 in your example, too. Okay? Let's do it. Challenge ourselves. Yep, put the 4. Put the 4. You're challenged by walking the front and the door, right? All right, what are the numbers? Let's look at the first 16x squared. What is the perfect square that's used in this case? 4x. 4 and x. Hang on, we're not there yet. Just 4x. Okay, and then how about, be careful with this one. Good, Louise. Okay, it's 9. You were right with the 9 with 81. But what number times itself, or what letter times itself, is equal to y to the 4th? Y squared. Because y squared times y squared, you add the exponents, so that's where you get y to the 4th. So 9y squared is the number that goes here. Okay?
So without that 4, it's gonna get 9y.
It would be 9y if it was y squared, yes, in the original problem. Very good. All right, so let's write our two factors and we're done. There's really nothing worse or nothing hard about this other than figuring out what the numbers are to begin with. So my two factors are what, Jennifer? 4x minus 9y and? Yeah, it's not squared. Oh, I'm sorry, 9y squared. Yeah, you got to say the squared. Good. She meant that. Sure.
Are we doing like each one of these when we look at it and just know what happened?
Well, that's part of it, is knowing which one of the patterns we're going to use, right? So far I've given you 5 different things. When would I use this particular example? So I think that's what you're asking, right? Like, how do I know when to use what? I think that's a good question. I think it's a really good question. If you have 2 numbers with a minus sign, 2 numbers with a minus sign, 2 numbers with a minus sign, that tells me it's a difference of perfect squares. Okay? All of the other choices, they were all trinomials. They had 3 pieces. So you have to think about what the first number is. If you look at your other choices, A is that leading coefficient. It's a number in front. So like, for example, this number in front. Okay? If it's a number in front, then we have A is greater than 1. Did you have that as an option? A is greater than 1, right? A is equal to 1. That's this case. Okay, so you're missing a couple. Okay, so let's look on and make sure we get the right tabs there. Jennifer, do you have all of them, right? You don't? Oh yeah. Why don't you look on and make sure you're not missing any tab? Because I think you should have all. Let's see, how many should there be? 1, 2, 3, 4, 5. There should be 5 right now. We're about to add the 6th one. Okay. So, are we okay with difference of perfect squares? It's something you don't see very often, but it's often enough that you could possibly use it. Before we do our last tab, let's look at this particular sheet. Go ahead and turn it over on the back for me. And I want you to let's kind of answer Chris's question. Let's identify those problems on the back where the difference of perfect square pattern would be the one we would use. So which ones would we use here? Look at the back. Which ones? Which numbers do you see? 31. Would you agree that 31 on the back is a difference of squares problem? Do you recognize why? So once you're finished putting those 4 into your onto your sheet that you're going to be turning in today, the last tab that we're going to add to our foldable is called the perfect square trinomial. And honestly, it's really, I honestly am just going to even erase this because I think this might even be confusing, okay? So let's honestly just look at dividing our page into 2, okay? So just do 2 here, and these are our 2 examples that we're going to do, okay? And add these to your foldable. And this is the last page we're going to add to our foldable, actually. And I'd like to go ahead and look at this last example, the perfect square trinomial. And we're going to look at 2 different examples. And I want us to look at these, honestly, as we would any other type of factoring. So I'm not going to change anything that we've done to this point until the very, very end, and I'll show you what you need to do. Okay? If you look at the example on the left, and I was like asking, I was kind of going with Chris's question, how do I know which one of these it is? What would you think if you look at this example? Is it a difference of perfect squares? How can I rule that one out? It's got a trinomial. Good. We can rule that one out. So it's definitely a trinomial. I've got a lot of choices with trinomial. I have a equal to 1, a equal to -1, a is greater than 1. Which one is this? What is the a on the left-hand side? It's 1. It's your leading coefficient. It's the number in front of the x squared. So because your a is equal to 1, that is the pattern we're going to use. So you should be able to flip that up if you want and figure out what we need to do. When a is equal to 1, if you remember, here, we go ahead and make our little organizational chart. And what 2 numbers go in it? 16, because it's 1 times 16, and then they multiply to be 16 and they add to be 8. Good. So let's think about the factors of 16.
So why would you say it's a equals 1?
Because the number in front of the x squared is 1. That is your a. Okay? All right, so what 2 numbers multiply to be 16 and add to be 8? 4 and 4. Very good. Now, in this case, you'll notice that these 2 numbers will always be the same. Okay? So we'll look at that. So look here. So if we're going to rewrite our middle term, and again, some of you guys know the shortcut for this when a is 1. We're going to go ahead and look at our first 2 and our last 2. We're going to group. What's the GCF in the first 2? X. When I take out an x, what's left? There you go, x plus 4. 100% has to be an x plus 4 with the second 2. Jessica, what's the number I can take out of the second group to leave me with an x plus 4? A 4. A plus 4. So that leaves me with my 2 factors. They don't put a squared when you're factoring. Okay, because x times x is x squared. That's what you're saying. Yes, that's where we're going. Exactly. The 2 factors, Bradford, you're right, are x plus 4 and x plus 4. They're the exact same factor. So it's not, and this is why it's called a perfect square trinomial. It's not exactly completely 100% factored until that step. Okay? I agree with you. This is correct. However, to be fully, completely factored, you do have to go this last step further, okay? When the 2 factors that you get are identical, you should write them together like this. For anyone where they're the same, okay? So I think you had one, I think it was, was it 29 or 30 last night? 30 was just like that. So look at question 30. Those factors should have been exactly the same. So take it one step further now. Take it one step further, and what should the answer be there? X plus 3 all squared. That's exactly right. Okay, so when the 2 factors are identical, you just take it one step further. So we know how to do it. We've done this factoring before. It's just kind of making sure that our final answer is written in the format we need. So let's look at this one last example here, okay, for our foldable. And then we're really done with our foldable for now. Okay, we'll come back to it when we get to polynomials later on in the year. But let's look at this one. Let's go back to Chris's question. How do I know, and I'm sorry that my backpack is right in the middle of your table. I just told, that's my lunch. Sorry about that, y'all. You didn't realize it was mine? Sorry. My bad. If you look at the right, how do I know which tab it is on my foldable? What is it a difference of perfect squares? We can definitely rule that one out. We have a trinomial. What's A? Nope, it's 9. It's the number in front of the x squared. So if A is 9, that simply means, she's not here, that we're going to be looking at A is greater than 1. Okay? So A is greater than 1. This number is bigger than 1. Okay? That's what that's saying. You got to go check in, honey. Okay, you got to go get a pass from downstairs. Oh, you already did. Look at you. I just sent a pass out from you, too. Can you go grab that lady, that person just walked? All right, so let's go ahead and look at, we know that a 9 is greater than 1, so A is greater than 1. So we're looking at that pattern. But because we're putting it on this perfect square trinomial thing, we can kind of guess that our final answer is going to look like the one on the left. One of those factors squared. Okay, Christian? Make sure you're writing this down, sweetie. Okay? So, how do I do this? What do I do? Who remembers? Not 12 and 4. You have to do the 9 times the 4 first. Okay? Because there's a number in the front. So what number do they need to multiply to be? 36. And they have to add to be 12. So these are the numbers that I'm looking for here. So what do you think? 6 and 6? 6 times 6 is 36. 6 plus 6 is 12. I agree with you. 6 and 6.
So if we use perfect square trinomials, we get those two numbers are going to be the same.
So let's go ahead and rewrite our middle term. 9x squared plus 6x plus another 6x plus 4. I'm just using the two numbers I picked to rewrite my middle term. Once I have 4 terms, Gabby, what do I do? What did I do over here when I had 4 terms? Right, I'm grouping them. Perfect. So I'm going to group the first 2 and the last 2. And I'm looking for the GCF to take out of the first 2. Joseph, what do you see there? 9x squared plus 6x. What's the GCF there? 3x. Very good. And when I take a 3x out, Shamar, what am I left with when I take a 3x out of the first 2? 3x plus 2. And I absolutely 100% have to have what over here? Which is 3x plus 2. And I take out of 2. Very good. Because 2 times 3 is 6 and 2 times 2 is 4. I agree. So my 2 factors at the end of the game are the one they have in common. So these, the one they have in common, and then the other 2 combine to give me this one. So I get 3x plus 2 here as well. Since those 2 factors are identical, I have to take it one step further, and we have to make it look like this. 3x plus 2, all quantity squared. Okay? So what I'd like for us to do is I'd like for you to finish, okay, 31 through 37. So you should be able to do problems 33, 35, and 37. So you only have 3 additional problems I'm asking you to do. They may or may not be perfect square trinomials. They might be, they might not be. But I want you to work on those, okay? So you're only going to get about 10 minutes. And in 10 minutes, about 8:05 or so, I'm going to collect this, and this will be a graded assignment. And then we are going to move on to something else. So you're going to have your next OPQ number 2. One problem quiz is what it stands for. And you've already had one. And remember, with OPQs, you can continue to retake them as many times as you need to. It's either all or nothing. You get a 10 out of 10 or a 0. Make one little mistake. So we want to make sure that we really understand it. Shh. No, it's good because that means that you're going to get it. All right.
Get it or you don't get it.
Well, then you will eventually get it because you can keep doing it as many times as you need to. All right, let's look at this example because this is one that you might see, or a similar type of question that you would see on your OPQ. Okay? Well, I want everybody to do it. Okay? So you want to look always first to take out a what? That's right. Is there a GCF here? There is one. So let's take out the GCF first. Okay? Let's do that first. And when I take out the 2, which you guys said was the GCF, what's left? 4x squared.
Plus 7x plus 3.
All right. Now, I am not completely factored. Because now I'm going to, the 2's along for the ride, isn't it? So I'm just going to go ahead and put it down here because it does go in my answer. We don't want to forget about it. And now I'm going to have to look at what's left inside the parentheses and see if I can factor it. Okay? So, Shamar already gave me the starting point. What do I do here? There you go. I'm going to multiply the 4 and the 3. And I'm going to do my little scratch work over here. Okay? 4 times 3 is 12. They're going to multiply to be 12 and they're going to add to be 7. Are there 2 numbers that do that? 4 and 3. Very good. So I'm going to rewrite my middle term. So I'm going to have 4x squared. I'm going to have the 3. But I'm going to rewrite with 4x and 3x. I'm going to rewrite this middle one. Plus 4x plus 3x. Now I'm going to group. So we've done this over and over. What is the greatest? Yes, ma'am. Nope, doesn't matter.
Wait, where's the 4 come from again? The 4x?
This 4x squared or this one over here? I use the 4 in the because these 2 numbers right here I rewrote to be these. So this is the way I do it. Remember, it's different than the way Miss Cannon does it. So I'm going to look at my first and my first 2 terms. What's the GCF? 4x. When I take out the 4x, what's left? X plus 1. Because when I take 4x times x is 4x squared. 4x times 1 is 4x. What has to be the term over here? There you go. What can I take out, Gabby? What can I take out of these 2 terms that'll leave me with an x plus 1? What times x is 3x? Okay, so we'll put a 3 here. Is 3 times 1 3? So I've got it factored. So my 3 factors, because remember 2 is also taken out, my next one's going to be what? 4x plus 3, and then my last one, x plus 1. Because these 2 make up a factor. These 2 are the same. Okay? If these 2 factors happen to be the same, and it was a perfect square trinomial, what would you do? Your last step would be to write them as 1 squared. Okay? Think you could do okay on the next OPQ? I'm not going to do, there's another one right here. This is like the 4th one we did today. Okay, so I'm not going to do another one. Okay, so this is definitely something you should be practicing. Okay, you need to be looking. I'll give you some problems in the textbook if you wanted to practice for homework, to practice for this next OPQ. But we are going to do one last thing today, and it is the last thing for this whole unit. Okay, so it's the last new thing. So you do need to take out your notes. Mondays and Wednesdays are my days to stay after school, from 2 to 3 o'clock. So go ahead and take out your notes. We're going to do the last new thing. Remember how we went from VertexForm to standard form on the first OPQ? And you multiplied the binomial, and you replaced and distributed and all that stuff? You don't? Okay, then that's maybe why you need to retake that OPQ. okay? Because that is something I expected you to do. If we can go from vertex form to standard form by multiplying it all out. Now we're going to go the opposite way. We're going to go from standard form to vertex form, okay? And this is going to be the last new thing. On Thursday, all we're going to do is review, and you'll have your test on Monday, okay? So test Monday on all kinds of factoring, on graphing parabolas, on standard form and vertex form.
Yeah, I actually took a good test for me.
Good. I think we all can. We all can get there. So let's just review for a minute, and let's make sure we remember when I say vertex axis of symmetry, max and min values. All right, so let's remember how to do this, okay? Which one of these three graphs is the graph of this one? Which one can I eliminate right away? There's one of them I can eliminate. The middle one. You're right. Why can I eliminate the middle one? Because it's going up. And what in the equation tells me that it has to go down? The negative in front of the 3. So I can go ahead and eliminate this answer choice right away. Good. So which one would be the left or the right here?
Oh, the left.
What's the difference between them? Well, they're both kind of stretched, but where is the vertex in each of these cases? So the vertex is here, and the vertex is kind of off-centered a little bit on the left-hand side. Which one do you think it is?
The one on the left.
It's kind of hard to tell, because really, we like things in vertex form, don't we?
-3.
Well, they're both upside down.
No,
This has nothing to do, that doesn't tell me where it's moved over. Remember, if it's moved like this is when vertex form, and that tells me it's moved right 1 up 3. Remember that? So we have to really change this so it looks like something in vertex form so we can figure out where that top number has gone. Okay? And I'm going to show you a shortcut to be able to do that. So here's what you need to write down. Okay? I'm going to try to make it a little bit bigger so we can kind of see it here. But this is what we need to write down. Okay? So we have a parabola. You don't have to write ax squared plus bx plus c, but it's probably a good idea to start with that. Let me get this started here. There we go. So here is the general form of a quadratic. So let's write that in our notes. F of x equals ax squared plus bx plus c. Okay, so go ahead and write that one down for me, just what I've highlighted. The a is the number in front of the x squared. Okay, the b is the number in front of the x, and the c is the constant term. We call that quadratic term, linear term, constant term. Ax squared is the quadratic term because it's got an x squared. Bx is the linear term because it's just got a plain old x. We know the parabola is up if a is greater than 0. It's positive. We know that it goes upside down if the number in front is negative. Y'all just told me that, right? We know that. You don't need to write the second bullet. Here is something we don't know. Please write that formula down for me. The axis of symmetry, if you have it not in standard form, if you have it not in vertex form, we can use this formula to come up with the vertex and the axis of symmetry. Negative b all over 2a. Okay? So that's one formula that we need to do. So you're going to write the axis of symmetry and the x-coordinate of the vertex is the same formula. Remember from OPQ number 1, if we were given this particular problem, negative b over 2a, yes. If we were given this problem, this is from OPQ number 1, could you tell me what the vertex is when it's written in this form? You should be able to. What is it? Nope. positive 1, 3. Right 1, up 3. Remember that? So you tell me the vertex. Based on the vertex, what could you tell me that the axis of symmetry is? X equals 1. So we know how to do it when it's in vertex form. I'm going to show you how to create the vertex if it's in standard form. Okay? Remember how we changed this to standard form before? Well, let's look at one that's in standard form right here. So here's our example for the day. Okay? F of x is equal to 5x squared minus 3x minus 4. That's a trinomial. Yep, we're not worried about factoring it right now. We just want to look at what the graph might look like. What is the vertex of the graph? Well, it's not in vertex form yet, but I can get it there. So let's look at it. If it's in standard form, I can do this formula, negative b over 2a. What's b? B is negative 3. So in this case, I have negative 3, and it's also negative. Over 2, and then what's a? Alexis? Yes. So this is a, this is b, and this is c. A is always with the x squared, b is always with the x, and c is always the constant term, which is why I had you write this formula here. A, B, C. Okay? All right, let's keep going. What negative b, we'll just write a, b, and c if that helps. Oh, write what a, b, and c are. A in this case is 5, b in this case is negative 3, and c is negative 4. Okay? Kind of to piggyback on Alexis's question. Looking at the numbers, that's how we came up with what a, b, and c are. Negative b. If b is already negative, can't I make it a positive? 2a. What's a? 5. So this is going to be 3/10. Ooh, it's a fraction. Is that okay? All right, if I have to, sure. That is the axis of symmetry. That is also the x-coordinate of the vertex. How do you think I could find the y-coordinate? How do I find this number? Well, you just plug it into here. Okay? So on your calculator, you should have your calculators out. We're going to have to plug in a fraction. That's okay. It's not going to kill us. We'll do it. I found negative 3/10 by using my formula. That gives me the x-coordinate of the vertex. The y-coordinate is simply plugging that in. So it's going to be 5 parentheses. Always, 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 always use parentheses. 3/10, and you can use a fraction if you want, squared, minus 3 parentheses, 3/10, minus 4. I simply plugged in the number I got into x. And I go ahead and I get a decimal, and I'm okay if you leave it as a decimal, or you can go ahead and go to math frac, and you can leave it in either one of those. I plugged it right into here, dear, so minus 4. Yeah. Okay. So negative 4.45. I am okay with you if you want to go ahead and write them as decimals. 3/10, by the way, is 0.3, if you remember from middle school. But you can just go ahead and write your vertex. Now this one had some fractions in it and was a little kind of awkward, no big thing. I'd like to look at one maybe that didn't have fractions, okay? And let's look at one where maybe it's not quite so ugly. Let me see if I can find one here. So let's try this one, okay? I have y is equal to, x squared plus 2x plus 5. And I want us to find the vertex. And actually, not only do I want us to find the vertex, I want to write it in vertex form. So write it in vertex form. What are we going to do? What's the first step? What's that formula that I gave you? Negative b over 2a. So anytime you're asked to go from standard form to vertex form, this is the formula I want you to consider. Okay? That gives us the axis of symmetry and the x coordinate. So let's identify what A, B, and C are. What's A? 1. What's B? 2. And what's C? 5. Good. So we know what they are. Now let's plug them into the formula. Negative, what's B again? 2 over 2 times 1. How does that simplify? Negative 2 over 2, which is negative 1. Chris, put your head up, dear. Come on. There's only a couple minutes left. I know it's rough. You got it. No fractions. That's a good thing. This is the x coordinate of my vertex. I need to find the y coordinate. How do I do that? Plug it in. Very good. So I'm going to plug it in. I'm going to plug a 1, a negative 1. Now be very careful. You have to use parentheses. If you don't use the parentheses, it won't work, folks. So when I plug this in, I have parentheses negative 1 squared plus 2 parentheses times negative 1 plus 5. What is the y coordinate? 4. That is the vertex. I can find it. Okay, I can find the vertex pretty easy. So I can go from standard form, if I have the vertex, how do I plug it in vertex form? Do you remember? This tells me I went left 1 up 4. Left 1 up 4. I'm done. I'm going to say it one more time. Left 1 up 4. Left 1 up 4. When it's in, this is when you were not here yet. When we were inside the parentheses, we do opposite of what you think, and that's the transformation. So up 4 because it's at the end, left because it's inside the parentheses and it's positive. Okay? Kimberly? I'm saying left 1, but yes, it is, no, it's left 1. It's left 1 because think about graphing, Kimberly. You're thinking it's opposite in the equation, not in here. So you're opposite going, it's in the equation that's backwards. Alexis? Say it louder. Are you sure? Okay. So you guys have, should we try one more just to make sure before I send you off and do homework? I want to make sure you really know how to do this. Of course you're going to have homework. Okay, of course you're going to have homework. All right, let's try one more just to make sure that we can do this. Okay, so let's try one more here. I want us to write this in vertex form. I want us to write it in vertex form. What form is it in right now? Standard form. So we're going to write in vertex form. When it tells me that, that's your clue that you're going to use the formula negative b over 2a. So I have to identify what a, b, and c are. Bradford, what's a? What number is a in this problem? Negative 1. What's b? Will? 3. Good. How about c? Ashame, what's c? Negative 1. Good. So once I figured out what a, b, and c are, I'm going to plug them into my formula. Negative b all over 2 times negative a. Sorry, 2 times a. Because a is the number in front of the x squared, which is -1, and c is the number at the end, which also happens to be -1. They're not always the same, just in this case. Once I plug it in, what do you notice here? I get -3 over 2. I'm sorry, -2. What's a negative over a negative? Positive. Can I just write 1.5? Is that okay with you guys? Because 3 over 2 is 1.5, right? So that's the vertex, or the x-coordinate. How do I find the y-coordinate? Plug it in. And I'm plugging it into here. Okay? So I've got to plug it in. So I'm going to say negative, then my parentheses, because the negative is out front of the x squared. The negative does not go inside the parentheses. So negative 1.5 squared plus 3 times 1.5 minus 1. I'm just plugging it into the equation. That's all I'm doing. And I get 1.25. Okay. You will get decimals sometimes, and I'm okay with that. You sure? Okay. So that's my vertex. How do I take my vertex and write it in vertex form? I went right 1.5 and up 1.25. Up 1.25, right 1.5. There is one thing I didn't do, though. The negative. There is a negative out in front. The negative goes out in front. I'm done.
Wow. A lot of stuff.
It's a lot. Today's a big day.
So it feels like I'm not even like learning enough. I'm just learning.
Well, on Thursday, so here's the deal. You're going to have some homework to practice with your vertex form. You do have an OPQ on Thursday. I'll answer your question in just a second. And then all we're doing Thursday is reviewing for your test. That's all we're doing. So we'll practice factoring some more. We'll look at vertex form and standard form some more. Okay? So we'll see if we can't do we'll incorporate a little game with it too to review for our test. Okay? Okay?